And so here's our configuration screen. So first thing you do is configure which board you want. I have pre-selected the OMAP 138.
And that would be also pre-selected by default when you download a factory from the, one of the starting points for the OMAP 138 EVM. So that should be preset for you. Yeah?
The target, the toolchain, and a few packages will already be selected and ready to go.
Okay.
So to get to the juicy part, we'll go down to the software and the packages, and down to multimedia and DSPLink.
I see.
So in here we have a number of options, some of which are unique to DSPLink. Namely, we have here you can use whether you want to use the debug or release profile. There's an option whether or not you want to install these sample applications that exercise the DSP just to sort of prove that it works.
And those sample applications, by the way, come as part of one of the binary packages from Texas.
Yes, that's part of the DSPLink distribution. So, and down here we have the part that you're actually responsible for customizing, the tools. This is where you specify the version and location of the different tools that you downloaded. So we have the BIOS, the code generation tools, and the XDC tools. All you need to do is you hit enter and you fill in the path to wherever you install them.
Okay, so this is the path on my local hard drive.
That's right.
Where I uncompressed those different components. And in your case, since you uncompressed everything to a single subdirectory, you're pointing to the training subdirectory and then to a specific subdirectory in that directory. Okay.
That's right. And then there are some advanced build options here. Mainly these are just options that are passed to the configuration. They will be pre-selected with the default for the 138 or whatever your board happens to be. You shouldn't have to change anything down here, but we did provide the option in case you wanted to experiment. Okay. So once you have that set up, you just have to back out and then it'll save the work order, and then all you have to do is type make. And it'll build everything. It'll build your kernel, your RFS, it'll build DSPLink, and it'll insert the DSPLink modules and the sample applications and libraries into the right places in the RFS, and then wrap it up in a neat little tarball for you to deploy on your board.
Excellent. So that means that I can also format my root file system for deployment in the onboard NAND flash.
That's right.
And I can say that I want to build a GFS2 formatted root file system. And that file system will have all the pieces that are relevant not only to my ARM application, but also HCI and Linux kernel modules and all the different components that are responsible for providing the connection to the DSP.
That's right.
Excellent. So can you show everyone where the binaries are located after the build is done and how to deploy those binaries on a target?
Sure. So the binaries are going to be placed in the RFS of your target. This I've just changed to the local copy of the RFS that's going to be deployed on the target. And TI recommends that you put these binaries in ops DSPLink, which I have done. So here you can see the DSPLink kernel module, and then each of these loop, message multi, etc. are sample applications. Mm-hmm. So if you look in loop, you're going to see loop GPP, which is the ARM application, and then loop.out, which is the DSP side application.
Okay.
And when you deploy this in the target, if you want to test it, all you have to do is go to this directory and execute this loop GPP with loop.out as the argument, and it'll take care of dispatching everything to the DSP as needed, and it'll show you a nice little output.
Okay. So this is actually an uncompressed version of the file system. But if you're deploying on a target, well, in your case, do you mount the file system here via NFS?
Right, when I do development, I do all my,
Okay. So this is the loop file system that you're going to NFS mount on a target.
that's right.
Okay. Now, is there any step involved in setting up a DSP site as you boot the board?
No, it's really just, once you get U-boot loaded on there, you just fire up the kernel and mount everything on NFS, or mount your NAND or whatever it is, and then the DSP link can take care of dispatching things to the DSP itself.
Okay. So can we go right now through, can we walk through the process of booting the board with the DSP link in place and then executing the loop GPP program?
Sure.
Okay, so we have a L138 reference board up and running, and the booting process is stopped at U-boot. So what are the next steps? We have, again, the Linux kernel and NFS settings in place.
That's right.
Right? So what are the next steps to put the Linux kernel here?
So we use our DHCP network system here, so it's all really easy to set up. You just say boot P and then boot M to boot the kernel. Okay. And it loads it up, executes the kernel, and looking for NFS.
Kernel messages. Excellent. Oh, that was pretty fast.
Yeah, it's a pretty minimal file system, not a lot running on.
Okay. So again, different TI binaries components are already preloaded in this file system. Right now that we are on the target, maybe you can navigate to those subdirectories to show what they are.
So everything is loaded into off DSPLink. So if we look in here, we have a kernel module and a couple of samples.
Okay, and we were talking, I believe, about the loop. Yeah. So let's start at DSPLink.
So just have to load the kernel module.
We led with the inchmon.
That's right. Loads it up, okay, and then we go into the loop directory. And you can see here we have the loop GPP, which is the executable for ARM, and then loop.out, which is the executable for the DSP.
Okay.
So all I need to do is execute loop GPP with arguments of loop.out. And then the way this particular sample application is set up, you just need to give it a couple of numbers. I think it's how many loops it takes and how much data it transfers in each loop. So let's give it 1024 and say 10,000 cycles.
Okay.
So we can go to that. And you can see it's a nice debugging output.
And the debugging output is from the application or from the DSP side?
This is all coming from ARM, but it's passing messages back and forth between the ARM and the DSP.
Okay, so the program is finished, and that's it, right?
Yeah, it's as simple as that.
We have talked about what it takes to set up a build environment, get the DSP link integrated with the build environment, what it takes to configure the factory build tools to include support for DSP link on the OMAP L138. We created binary images and just deployed it on a target. That was pretty easy.
Yeah, it's really no sweat.
Well, we hope that you're going to have a similar experience with our tools, and if you're going to run into any challenges, please do let us know. We're here to help.